This is lesson 3.1 on parallel lines. So first of all, definition of parallel planes. Parallel planes are planes that do not intersect. So I've drawn a little cube over here. Well, maybe it's a rectangular prism. I don't know that all the sides are the same. It kind of looks more like a rectangular prism than a square prism. But for example, the top and the bottom of that figure would represent two parallel planes. Okay, now for lines. Lines either are intersecting or they're not. So if two lines intersect, then we know their intersection is exactly 1 point. But some lines don't intersect. Now here's what's a little different. A lot of times students think that if lines don't intersect, then they have to be parallel to each other. But there's actually another situation that can happen. So lines are parallel. The definition is lines are parallel if they don't intersect, but also they have to be coplanar. That means that there is a plane that can go through the two lines. So for example, let me make it a line. This line and that line are parallel because they're not going to intersect and they're in the plane, which is the top of the box there. Likewise, that line would be parallel to this line because there's a plane that would go kind of like diagonally through the box here that would catch those two lines down to the middle. Okay, not the greatest picture, but you get the idea. Okay, so we know what parallel means. Parallel means lines don't intersect, but also they are coplanar. Now there's another term which you may or may not be familiar with, and that's skew. Okay, lines that are skew also do not intersect. Students are not as familiar with skew lines, but here's an example of skew lines. Because skew lines are not coplanar, you got to make sure you pick two lines that don't intersect but are also not in the same plane. So for example, I'm going to use segments here. If you used this segment and this segment, for example, okay, even though if you stretch that out, it looks like they intersect, remember, they're really not going to because they're in different planes. So think physically about what it would look like if you had a tissue box in front of you and you highlighted, whoops, sorry about that, you highlighted like this segment and that segment, right? They're never going to intersect. So that segment and this segment, they'll never intersect. Now you don't want to pick one like this because they're actually parallel. There's a diagonal plane that would catch them. You don't want to pick one like this because they're parallel. Okay, you want to make sure you pick them so that they're never going to intersect. So like this one and that one, for example, are skew. Okay, so here's an example. Looks like a little block of cheese here. Name two parallel planes. So parallel planes, for example, MNO, the top, and PRQ, the bottom. Or, now you only had to give two, and I'm going to give you another example. Or, oops, I can't give you another example because this one doesn't have any other parallel planes. Okay, if I was looking at a rectangular prism like up here, you'd have three sets of parallel planes because all of the opposite faces would be parallel. But on our little block of cheese down here, we only have two parallel planes. Okay, now two planes that are not parallel. NMR would be kind of like the back plane and the front NPQ. Remember, you can use any three non-collinear points to name a plane. Another pair of non-parallel planes. PRQ, the bottom, and the face that's MOQ. Okay, those intersect, so they're not parallel. Now, two pairs of parallel segments. So let's say segment MR is parallel. If you don't remember that notation, that means parallel. Segment MR is parallel to segment NP. There's an example of two parallel segments. And then another pair of parallel segments would be like a segment NM would be parallel to segment PR. And then two pairs of skew segments. So this one you want to make sure that you're careful that you grab ones that are not parallel. So for example, and also not intersecting, okay? Skew segments cannot intersect. So you wouldn't want to use like NM and OM because they intersect. You don't want to use NM and PR because they intersect. So let's grab NM and then OQ. So something like segment NM and segment OQ would work. Or how about segment MO and segment PQ? Now again, remember the idea of skew is that they never intersect, but they're also not coplanar. So you want to make sure they're neither intersecting nor parallel. So another way to think of skew is are not intersecting nor parallel. That's your definition for skew, is non-intersecting and not coplanar. So make sure they're not intersecting and they're also not parallel. Okay, the second main idea is going to be different kinds of angles that are formed by what we call two lines that are cut by a transversal. So in this diagram, you have two lines here. It's a little thick. Make that a little bit thinner. You have two lines that are cut by a third line, which is called a transversal. So in this diagram, I'm going to label the transversal T. Okay, here's what a transversal is. A transversal is a line that intersects two or more lines in a plane at different points. A line that intersects two or more lines at different points, and then it's in a plane. Okay, so two dimensions, and there could be two lines, or three lines, or four lines, but your transversal has to cross all of them at different spots. Okay, so in this picture are two blue lines that are given lines, and the transversal is the orange line T. How many angles are formed? Well, as you can see, they're numbered. There are 8 angles there. Some of them are interior, and some of them are exterior. Now, what I mean by that is interior angles are the ones that are between the blue lines. So which angles, kind of ignore the transversal for a minute, which angles are interior in between those two lines? Well, that would be angle 1, angle 2, what else? Angle 5, angle 6. Okay, those are interior, so think of it like they're between the two lines. That's why they're interior angles. Oops, don't want to do that. Okay, and then we've got some angles that are exterior. Exterior would be everything outside of those two blue lines. So that's going to be angles 3, 4, 7, and 8 in this particular picture. Obviously, the numbering of the angles could change if you had a different diagram. Now, in those interior angles, we can kind of specify two different types of interiors. The first one is alternate interior. Alternate interior have to be interior angles on opposite sides of the transversal. Okay, so if you picked angle 2, for example, the alternate interior needs to be another interior angle, so you can choose from 1, 5, or 6, but it has to be on the opposite side of the transversal, so that rules out number 6. And then also it should not make a linear pair, because 1 and 2 already have a name. They're a linear pair, so we don't want to rename those. We want to say 2 and 5. Okay, 2 and 5 are called alternate interior because they are interior angles that are on opposite sides of the transversal. But again, they do not form linear pairs. So the first kind of special angles there are alternate interior angles. So angle 2 and angle 5, these are pairs of angles, so they'll go together. And then the other pair would be angle 1 and angle 6. All right, alternate, oh sorry, let me stick with interiors here. Consecutive interior. Consecutive interior angles are again interior angles, but this time they are going to be on the same side of the transversal. Okay, a pair of interior angles that are on the same side of the transversal. So let's say we grab angle 1. Well, there's 2, 5, and 6 are all interior angles, but the only one that's on the same side of the transversal as angle 1 would be angle 5. Alright, so we've got angle 1 and angle 5. Where is the other pair of consecutive interior? Now the word consecutive means like in a row, like one after another. So they're kind of like following each other when you walk along the transversal between those two blue lines. So your other consecutive interiors would be angle 2 and angle 6. Okay, now the other specified options here are for your exterior angles. Exterior angles again can be alternate. It's not alternating, it's alternate. Sometimes students want to call those alternating. Alternate exterior are going to be a pair of exterior angles that have to be on alternate sides of the transversal, so opposite sides of the transversal. But again, you don't want to use linear pairs. So alternate exterior should be like angle 3. And then on the opposite side of the transversal, again, you don't want to grab 4 because they're a linear pair. So 3 and 7. Outside of the two blue lines and on opposite sides of the orange line. So angle 3 and angle 7. What would be the other pair of alternate exterior? Well, if we grabbed 4 as an exterior angle, its alternate exterior angle would be angle 8. So angle 4 and angle 8. Okay, and then same thing like with interiors, the consecutive exterior angles. So consecutive exteriors will be exterior angles that are on the same side of the transversal. So consecutive exterior. 3 is an exterior angle. Its consecutive exterior would be angle 8. And then your other option would be 7 is an exterior angle, and so it would be consecutive exterior with angle 4. Okay, and then the last type of angles that go along with these two lines cut by a transversal are what are called corresponding angles. Okay, corresponding angles are angles that are basically in the same position. Sometimes these are hard for students to see, but let me explain what I mean by the same position. So corresponding angles would be, for example, angle 3, and then what other angle is in the same position as angle 3? Well, angle 3 is on the right side of the orange transversal and above the blue line. So down here, where is there an angle that is on the same side of the orange line as angle 3 is, but also above the blue line? Okay, so that would be angle 6. They're both on the right side of the transversal and above the blue line. So angle 3 and angle 6 are what are called corresponding. They're in the same position. If you said angle 2, well, it's on the right side of the orange line, but it's below the blue line. It's kind of like lower right corner. So then down here, what's in the lower right corner? Well, it's angle 8. So that would be angle 2. Oops. Angle 2 and angle 8. All right, what about 5? Well, 5 is kind of upper left or like northwest corner. And so on the left side of the orange line and above the blue line would be angle 4. So 4 and 5 correspond. And then lastly, 1 and 7 would go together. Angle 1 and angle 7. Alright, so again, interiors are the ones, to kind of recap here, interiors are between the lines. Some of them are alternate interior on opposite sides of the transversal. Some of them are consecutive interior on the same side of the transversal. Okay, some of the angles are exterior angles, and then you've got ones that are on opposite side of the transversal. They're alternate because they're on opposite side of the transversal, and then exterior because they're outside the two blue lines. Then you've got ones that are exterior but on the same side of the transversal, like 3 and 8. Both outside the blue lines, but both on the right side of the transversal, so on the same side, so consecutive exterior. And then finally, corresponding are going to be in the same position. Now notice that with corresponding, you'll have one interior and one exterior every time, but you have to make sure they're in the right position. Okay, so they aren't both interior, they are not both exterior, there will be one interior and one exterior. And again, they need to be sort of in the same position in the diagram. Okay, so here's some practice problems. Give the special name for each angle pair listed. Alright, for angle 3 and angle 7. 3 and 7. 3 and 7. Well, they're interior. Let me highlight the lines here. I think that'll make it a little better. That's a little thick. Okay, so here's the two lines, and then the transversal would be the one that's cutting it in two different places. Okay, so 3 and 7 are the interior or exterior? Well, they're interior. They're between the two lines. And then are they consecutive or are they alternate? Well, they're on different sides of the transversal, so those are alternate interior. That's how we can abbreviate that. They're alternate interior angles. Okay, 4 and 8. 4 and 8. Well, they're both exterior angles. Are they on the same side, which would make them consecutive, or are they on opposite sides of the transversal, which makes them alternate? Well, they're on the opposite sides of the transversal, so they're still alternate, but they'll be exterior angles this time. Alt-ext angles means alternate exterior. right? 5 and 7. Well, let's see. 5 is here, 7's there. Well, they're not both interior, they're not both exterior. So are they corresponding? Are they in the same positions? Yes. Those are corresponding angles. All right, we'll abbreviate that with 2 R's. Corresponding angles. And then 2 and 3. Angle 2 and angle 3. They're both between the blue lines, so they're both interior. But this time they're on the same side of the transversal, which makes them consecutive interior angles. All right, and then 2 and 8. What are those? Well, there's one interior and one exterior, but that's actually nothing new. What is it when you have two intersecting lines and you use the ones that are across from each other? Well, those are vertical angles. Vertical angles and linear pairs are still special pairs of angles, so you want to watch out for those because not all of these will have to do with two lines and a transversal. Okay, I would suggest you pause the video right now and try the ones on the right column over here, and that way you'll see if you're getting it. All right, 1 and 5. 1 and 5 are alternate exterior. I do not want you using any other abbreviation. I don't want that or alternate interior. Some teachers will let you do that. I do not want you to use those abbreviations. Okay, angle 3 and 6, what are those? Well, they're actually a linear pair. I'll write that out. They're actually a linear pair. Okay, the next one, 6 and 7. Consecutive interior. 2 and 4. Consecutive exterior. And then 1 and 4. Oh, I said the wrong thing. Oh, my bad. 2 and 4. 2 and 4 are actually corresponding. And 1 and 4 are consecutive exterior. Okay, moving on. Sometimes you'll have like 4 lines in the picture, like this one. And when you have that, when they name a pair of angles, you want to sort of pay attention to which lines are actually necessary to form those angles. So for angle 1 and angle 12, what line is necessary to make both 1 and 12? Well, one uses this line, and 12 uses this line, but R is the one that's common, that's forming needed for both angle 1 and 12, which means R is the transversal. So when you're answering these, you're going to first state the transversal, which these are supposed to be cursive letters, so lowercase r, and then how are 1 and 12 related? Well, they're alternate exterior angles. Okay, 7 and 13. 7 and 13 both need this line, but they're also 7 needs that line and 13 needs that line. So which one's the transversal? Well, the one that's common would be your transversal. So T is the transversal. It's needed for both angles. And then how are 7 and 13 related? They're consecutive interior. All right, 4 and 9. What line is needed for both of them? Well, let's see. This is needed for 4 and for 9. And then we need these other lines. So the transversal would again be R. And it would be 4 and 9 are alternate interior angles. And then 6 and 3. So 6 and 3 both use that line. And then 6 requires this line and 3 requires that line. So your transversal would be which one? Well, it's the common one, so it would be L. And 6 and 3 are alternate exterior angles again. And then 14 and 10. So the line that's needed for both is that one. And then they each require 14 and 10 both require those. So your transversal would be line M. And then your relationship here, 14 and 10, are corresponding angles because they're in the same position. All right, this is the end of lesson 3.1.